Okay, so welcome back, and we continuing with our trig equations, and let's have a look at this one over here. So what we've got here is a trinomial, right? We've actually got tan squared theta minus tan theta equals 12. So this will factorize. Well, let's subtract 12 from both sides first. Tan squared theta minus tan theta minus 12 equals 0, right? So this will factorize to tan theta and tan theta. And then we want factors of 12 that differ by -1. So differ by 1. We're going to need -4 and +3. Now, from here, tan theta equals 4. Or tan theta equals -3. Some teachers like to teach this with a substitution. So in other words, they let k be tan theta. Don't think it's really necessary to do that, but you could. And now both of these are just vanilla flavored trig equations. We're not actually going to continue this, right? But we would find our key angle. Remember, we don't put the negative values in, okay? And then these ones, the answers are going to be in quadrants 1 and 4. So 1 and 3. And this one in 2 and 4 because tan's negative. Okay, the next one looks similar, but it's not quite as simple because we've got cos squared and we don't have coses here, we've got sines. Now here is where we need to be a little bit sneaky because we need to remember that sine squared plus cos squared is 1. So if sine squared plus cos squared is 1, then in fact cos squared is 1 minus sine squared. And if we substitute this value for cos squared, sorry, I just realized that's fallen off the top of the page. If we substitute that value there for cos squared, then we're going to get a trinomial in sine squared. Let's see how this is going to look. We're going to get 3 into 1 minus sine squared theta plus 2 sine theta minus 2 equals 0. Right? It's going to be -3 sine squared theta we've got a +3 and a -2, that's +1, and we've got a +2 sine theta. Okay, and so that's equals 0. It's just fallen off the page there a little bit. And now what we've got is let's multiply through by -1 on both sides. So we're going to get 3 sine squared theta minus 2 sine theta minus 1 equals 0. Okay, and so this is going to factorize to 3 sine theta and sine theta and a +1 and a -1. And in fact, we're going to need to put the -1 there to get -3 sine theta plus 1 sine theta. Right, now, this is now sine theta equals -1/3. And that's fairly, sorry, -1/3, not -1/2. That's fairly straightforward from here. That is vanilla, all right? We're not going to continue it. The answers are going to be in quadrants 3 and 4. We're going to get our key angle and we're going to add 360k to both of our solutions, right? The other alternative here is that sine theta equals 1. Now, sine theta equals 1 is slightly more interesting because it's an extreme value on the sine graph. Okay, and if we remember what a sine graph looks like, it looks like this, and sine only gets up to 1 once every 360 degrees, and that happens at 90 degrees. So the solutions to this piece are theta is 90 degrees plus 360k, because the next time it will happen will be 360 degrees ahead or 360 degrees behind. So 90 plus 360k for our general solution. Okay, don't forget k an integer. Okay, we're going to ask you to pause the video and to try the next four. They're a mix of examples. Okay, they're a mix. And in fact, there's a whole lot of different techniques involved in these next four. So have a go. Right, so the first one is one involving sine and cos with different angles. So what we're going to do is we're going to change the sine into cos of 90 minus theta. We're going to leave this one as cos of 2 theta plus 20. Now, remember when we've got cos equal to cos, either the one angle equals the other angle, right? Or the one angle equals the negative or 360 minus of the other angle. I'm actually going to go with the negative this time. Negative 2 theta minus 20 degrees. Sorry, minus 20 degrees. And that's both of these are plus 360k. And for both of these, k is an element of z. Okay, from here it's just algebra. If we subtract 2 theta from both sides, we get negative 3 theta. Here we've got negative 70. When we divide through by negative 3, we get 70 over 3 minus 120k. That's from the top one. All right, or here, if we add 2 theta to both sides, we just get theta here. If we subtract 90 from both sides, we get negative 110. So theta is minus 110 degrees plus 360k. Okay, right, the next one. What does that look like? Well, absolutely. That definitely looks like a quadratic, a trinomial. Tan squared theta plus tan theta minus 6 equals 0. So let's try and factorize that. And it factorizes to tan theta plus 3, or tan theta and tan theta minus 2. So tan theta is minus 3, or tan theta is 2. Right, tan theta is 2 means we'd be looking for answers in quadrants 1 and 3. The key angle is 63,4 for tan, equaling 2. This is one that I happen to know. Right, so here our answers are just going to be 63,4 plus 180k. All right, and on this one, we're going to need to get a calculator to find the key angle. Remember, we don't put the negative into the calculator to get a key angle. We get 71,6 degrees. Okay, so 71,6 degrees. But this time, in fact, we want to be in quadrants 2 and 4. So 180 minus 71,6 is actually going to be 108,4 degrees. 71,6. 108,4 degrees. So our final answer is going to be 108,4 degrees. Because it's tan, we can just take one of those answers and add 180k. For both of these, somewhere in this page, we need to fit in that k is an integer. K is an element of z. Right, and so there's our final answer to that one. Okay, the next one involves sine and cos, but they're both operating on the same angle. So we can use our trick of dividing by the cos of the angle. So we're going to get 5 tan of theta minus 12. And here we're going to get 3. So in fact, tan of theta minus 12 will be 3/5. Now we need to find a key angle. Remember, if tan's positive in these two quadrants, so we're going to shift tan, we're going to undo tan of 3/5. Shift tan of 3/5. And we get about 30, let's round that to 31 degrees. Okay, so 31 degrees. And so 31 degrees plus 180k, but don't forget that that's not theta, that's theta minus 12. So in fact, our final answer, if we add 12 to both sides, is 43 degrees plus 180k. That is our general solution. Don't forget, k must be an integer. Okay, right, and there we have it. The last one is a trinomial. Yeah, but it's a trinomial in a little bit of disguise, because what we're going to need to do is we're going to need to switch out cos squared theta with 1 minus sine squared theta. So what we're going to get negative 6 into 1 minus sine squared theta minus sine theta plus 5 equals 0. All right, this becomes 6 sine squared theta minus sine theta. From the brackets here, we've got a negative 6 and a positive 5. It's negative 1 equals 0. Now we want to try and factorize this. Okay, and the factors of 6 are either 6 and 1 or 3 and 2, but I've got a good feeling about 3 and 2. 3 sine theta and 2 sine theta. All right, and we want a negative sine theta overall, so we want negative 1 here to give us negative 3 sine theta, and a plus 1 here to give us plus 2 sine theta. Okay, that'll give us our negative sine theta. So now we've got that sine theta is negative 1/3, right? Or sine theta is 1/2. Okay, this one's very straightforward because 1/2 is a key angle, a special angle rather. It's 30 degrees. And so our answers here are going to be that theta is 30 degrees plus 360k. And the one in the second quadrant is 180 minus 30, which is 150 degrees plus 360k. Okay, but this one, well, I'm going to need a calculator. I don't know what the undo sine of 1/3 is. Remember, we don't put the negative in. Shift sine of 1/3, and we get about 19.5 degrees. But for this one, we've got 19.5 degrees as our key, but we want to be in quadrants 3 and 4. So we get into quadrant 3 by going 180 plus, we get into quadrant 4 by going 360 minus. So our solutions here, 180 plus, that's 199.5 plus 360k. And 360 minus is actually going to be 341.5. 340.5 plus 360k. All right, and somewhere we are running out of space. We need to remember that we must write k is an integer. Okay, all right. So these are mixed equations. Okay, before the next lesson, we're going to ask you to try the remaining 4. They're the last few of equations that we're going to do, and then we'll go over them next time. All right, have a good day.